All right. Um, so introduction to scientific notation. Scientific notation is useful when working with very large or very small numbers. It's based on the powers of 10. And if we just review powers of 10, 10 to the 0 is equal to 1. Anything to the 0 power is 1. 10 to the first is 10. 10 squared, 10 times 10 is 100. 10 cubed was 100 times 10, or 1,000. And notice these are just our decimal places. And also the number, the exponent, is actually the number of zeros, or the number of decimal places after 1. So 10 cubed would have 3 zeros after 1. 10 to the 6th then would be a 1. And we have 10 to the 6th, so we need 6 decimal places, or 6 zeros to the right. So this would be 1 with 1, 2, 3, 4, 5, 6, or 1 million. With negative exponents, then the decimal place is basically moving to the left. So 10 to the negative 1 is the same as 1/10, or 0.1. 10 to the negative 2 is 100th, or 0.01. 10 to the negative 3 would be 0.001, or 1,000th. And again, if you look at the negative exponent, it is the number of decimal places to the right of the decimal. So 10 to the 5th, 10 to the negative 5th, we have negative, so this would be a 0 point, and we want the 1 in the 5th decimal place. So 1, 2, 3, 4 zeros, and then a 1, and this would be in the 5th decimal place, or 5 decimal places, right? So we can use positive powers to represent big numbers, and negative powers of 10 to represent small numbers. So scientific notation is a number written as n times 10 to the nth, where capital N is a number between 1 and 10, and it's times 10 to the nth power. So if the number is large, we notice that n, the power of 10, will be positive. And if the number is small, then the power of 10 will be negative. So just as an example, if we want to write 1,450,000,000 in scientific notation, the first thing we look at is this number is large. So since the number is a very large number, then n will be positive. So we're going to look to place the decimal so that the first number is between 1 and 10. So the decimal place, I like to say, goes right after the first significant digit. It should be right here. So in scientific notation, we would have capital N as being 1.45. Now we're going to multiply that times 10 to the, and we need 10 raised to a power so that we can move the decimal place to the right 9 places. So if I count the number of decimal places, this would be 9 decimal places. So the power of 10 would be 9. All right, so for the next problem, we notice that this 0.0005 is a very small number. So therefore, the power of 10 will be negative. So again, the decimal needs to be to the right of the first significant digit, or a number between 1 and 10. So we start this out with 5, and I need how many decimal places? So if I count the decimal places, there's 4. So this would be the same as 5 times 10 to the negative 4th power. Right, so again, we can use the positive and negative powers on 10 to basically manipulate decimal places. So let's try going back and forth between standard form or number form and scientific notation. So again, you could stop the video and try this, and then just watch the video when we're done. But so first of all, this first one, 46,700,000, we know this is a large number, so n should be positive. We should have a positive power on n. So what we do is we look for a decimal place just to the right of the first significant digit. So 4.6, we would want the decimal place here. So in scientific notation, it would start out with 4.67 and then times 10 raised to the, and now I need to count the decimal places from where the decimal is, would be 3, 6, 7 decimal places. So I want this to be 10 to the 7th. So now we have the next one. This is a very small number, so we know the power is going to be negative. The decimal place should be between the 3 and the 2, so it should be here in scientific notation. This would be 3.22, and then we need to multiply that by 10 to the, and now we just need to count the decimal places. So from here back to here, we'd have 1, 2, 3, 4, 5 decimal places. This would be a -5 then to represent that number. So now if we have something in scientific notation, how do we move it back? So the 5.2 times 10 to the -3 is again a small number. It has a negative exponent. So in this case, we're going to start the number 5.2 and move the decimal place back. If we want to write it in center form, we want to move it back 3 places, 1, 2, 3. So to do that, I would have to add 2 zeros in front of the decimal. So our number would be 0.0052. So the next problem, we notice this is a positive exponent, so this is going to be a large number. We have again a positive exponent. So what we need to do then is we have the decimal 9 point. We need to move the decimal to the right 8 places. So we're going to move it to the right 8 decimal places. So by doing that, I'd have 9. 001 would be 3 places. And now I need 5 more zeros to get the rest of the decimal places to 8. So this number then would be 900,100,000. So 113 or 113 is a large number again. It's actually bigger than 1. So this is a large number. We want a positive exponent. Again, we want to place the decimal place in our scientific notation right after the first 1, so that that first number is between 1 and 10. So this would be a 1.13, and then we're going to multiply by 10 to the, and I only need 2 places to move, so this would be times 10 to the 2nd place. In our last problem, we see that this is a negative exponent. So this is going to be a very small number. So we start with 6 point, and we want to move the decimal place to the left. So 6.0, if we move it to the left 9 places, we would have 8 zeros and then our 6. So we'd have to use placeholders. It got kind of messy, but it would be 0.12345678 and then the 6. So a total of 9 decimal places. All right, so when we use calculators, a lot of calculators won't have enough decimal places on their screen to write bigger, very, very small numbers. And when we calculate, we want to be able to input scientific notation and then read from the calculator the scientific notation that comes back. So for your specific calculator, you can like Google your calculator, look up your model in scientific, or excuse me, look up your model with scientific notation. Like if you have a TI-30 2 with scientific notation, you could look that up. Here I got a couple examples where I did some calculations that you could try with your calculator. Here are the answers. But just practicing inputting scientific notation into your calculator and then reading it from your calculator. So the specific examples I have, I just pulled from the internet, and you could probably find better ones, but this first one is calculating with the Casio calculator, and the next one example is calculating with the TI-84 calculator. So again, scientific notation, just moving decimal places back and forth.